Hope you guys can participate and answer the questions. Alright, we'll be starting now. Okay, question number 1. An arithmetic progression and a geometric progression have the same first term. Both have the same common difference and a common ratio, which is 1/2. The seventh term of the arithmetic progression is 13, while the 11th term of the arithmetic progression is equal to the sum of n of the first term in geometric progression. Find the first term of both progressions. So you have to find the first term for arithmetic and also geometric progression. And question B is, after finding that, you have to find the value of n. And since we already discussed the whole chapter, I want one of you to try this question. If you guys volunteer, it would be better. Try to engage yourself and answer the questions. Anyone can try? It's only 2 marks, so the working is quite short. Hello? Anyone can try? First,
Anyone want to try? Can leave the answer in chat box also.
Okay, I'll just show the working since there is no responses and we shall not waste time. So to find the first term for both progression, basic algebra, if you like solve this, you will get A is equivalent to 10. Continuing with B, I hope you guys understand for A. So the value of B, I'll show the working first. You have to use the SN formula. Or you can insert log. So the n is equivalent to 2. So Jivendran will be
What side lot?
Okay, so for A, I think you all should have understood because it's quite easy. I'll explain B. So they asked to find the value of n, and you can use the Sn formula and just substitute the values inside, and then after substituting we'll get Sn equals to 15, and then after that and then after that we can equate it with 1 over 2n equals to 1 over 2 square, and then since the base are same, we can just cut the base and you can write n equals to 2. So then answer is 2. So understand, we can go to the next question.
We try to do first. Okay, we shall discuss now. I really hope at least one person can try to answer. Okay, there's no point if only both tutors discuss. Okay, so question number 14. If A is the first term and R is the common ratio of geometric progression, show that the sum of infinity of the progression is this formula. This is proving thing, if I'm not mistaken. Okay, so we shall discuss it first. Okay, so that's it for A. Okay, and continuing with B, diagram 9 shows a pattern that repeats itself to infinity consisting squares and shaded triangles. The length of a side oblique square is 6m. Okay, we'll find the base length of the fifth triangle. Alright, and find the area of shaded region also. Okay, so sorry. You can do like this, or you can also do using the listing method. Which is like 3 over 2, 3 over 4, 3 over 8, 3 over 16, and etc. Continue. Okay? So if you use a calculator, you'll be getting 3 over 16. So if you use the listing method, it will be T5 is equal to 3, 16. That's B1. Continuing with B2. B2 is find the area of shaded region. Area equal to 1 over 2 times 3 times 3. So this is the answer for B2. So Jivinder will be explaining after this.
Okay, for A, it's proving we did last week, so I think most of y'all should know. Since n equals to infinity, so r to the power of n will be equals to 0. If you put infinity in r to the power of n, you can't get answer, so you assume it's 0. And then we use the Sn formula, and we read S infinity equals to A 1 minus 0, since we know r to the power of n is 0, and over 1 over r, then you'll get the formula S infinity equals to A over 1 over r. Okay, so that's how you get for A. For B, they're asking the base length of the fifth triangle, so there's two ways of doing. Either you can do using the formula or listing. If you guys use the formula, you guys should use Tn formula for geometric progression. Okay, why geometric progression? Because the lengths are reducing in division term, not by addition or subtraction. Okay, so if we guys use the formula, which is Tn equals to A r to the power of n minus 1, we can just substitute from the values from the question, and you guys will get 3 over 16. If you guys do the listing method, then you guys have to list 5 times, and you guys will get 3 over 16 also. Okay, so for for B2, area of shaded region, at first we have to find A, which is 1 over 2 times 3 times 3, the area for the triangle, for one triangle, the big triangle. And then since it's repeating and repeating, so we will have to use S infinity formula. Okay, so you just sub the A because S infinity is equal to A over 1 over R. So you already find the A on top, and you also found the R, which is 1 over 2 times 1.5 times 1.5. Divide 1 over 2 times 1 times 3 times 3. You get that is your dividing term 2 over term 1. Okay, and then you just sub all the information in the formula and you'll get 6 cm square. Okay, make sure to write the unit, if not they will cut the marks. Understand? You can go to the next question if everyone understand.
Continuing with the next question. The nth term of geometric progression is given by Tn is equivalent to Pq power of 2n minus 1. If the fifth term of 16 times and the third term, find the common ratio where r is bigger than 1, and it is 4 marks. So I'll be giving you another 2 more minutes to try. Please at least try to respond in your chat. We shall continue. So for question number 4, can cut also. Okay, so Jivendran will be explaining.
Okay, so the question said the fifth term is 16 times the third term. That means T5 equals to 16 T3. Okay. And then since the question has given the equation Tn equals to Pq to power of 2n minus 1, you can substitute the n value into the equation. So you all will get Pq 2 in bracket 5 minus 1 equals to 16 Pq 2 to the bracket 3 minus 1, and then you guys will get then you guys can simplify and you guys will get the value q equals 2. So after you find the q value, you guys can find the r value also, which will be r equals to 4. So that's the answer.
Okay, moving into question 5. Given the sequence, a sequence with the sum of first n terms is given by Sn is equivalent to 2n squared plus 3n, expressed as n minus 1, hence find the interval. And show that the sequence is an arithmetic progression. Okay, you have to find the sum of the first n terms, which is Sn is equivalent to 2n squared plus 3n. So, S n minus 1 equivalent to 2n squared minus n minus 1. So Tn is equivalent to 2n squared plus 3n minus 2n squared minus n minus 1. So to copy this, put it here. So Tn is equivalent to basic things again, 2n squared plus 3n negative 2n squared positive n positive 1. Tn is equivalent to 4n plus 1. You'll be getting 3 marks. 1, 2, 3. Question B. Show that the sequence is an arithmetic progression. So, you get T1 9 minus 5 is equivalent to 4. And this one is very important because we have already learned this in few classes ago. The recent classes. For. So D is equivalent to 4, which is with metric progression. Okay, can you all understand? Okay, moving on to next question. Okay, given 3q minus 2, q plus 3 and q are the first three terms of arithmetic progression 1, 2 and 3. Find the value of q. So value of q is 4. This is very basic, so there's the explanation is like very short. I'm sure you all can understand by looking at the steps. Moving into B, find the sum of the 7th term to the 14th term. So in the middle there's 7 difference. Okay, utilize your calculator, type everything slowly without making any mistakes. answer is negative 148.
Okay.
Okay.
So
Can I
I'll
explain?
explain. Okay, so first question is very easy, like very basic question. So you can just take the third term minus the second term, and then you can equate it with the second term minus the first term, because the ratio will be the common difference will be same. So then you can solve, move around, and you get q equals to 4. Okay, and then for b they're asking sum of 7 term to 14 terms, so just like up you say there's 7 like terms in between. So it will be S14 minus S6, because you take the total sum of 14 terms and then minus with the first 6 terms, so you'll get the 7 terms. Okay, then you can just substitute in the formula with the information you have, where a equals 10 and common difference negative 3, then you will get the answer negative 148. That's the answer. So next question.
Question number 8. Given that a geometric progression AR square, AR cubed, AR power of 4, and continue with AR power of n minus 2 and AR power of n minus 1. Deriving the formula is proving question. Very important. Okay, so this is proving. Proving not much explanation, because we already did one whole lesson about proving last week, so I hope you guys remember, or if you don't, please watch the YouTube video again. The range of values of r is negative 1, 1.
Okay, so I'll explain now, but I won't explain very detailed because it's proving. We already did last week. They're asking us to derive the formula for Sn a 1 minus r to the power of n over 1 minus r. So as I said in the last class, you just list out term 1 plus term 2 plus term 3 and so on, and then you write ar plus ar square plus ar cube and so on, and then you have to use Sn minus Rsn. Remember I told you must do two equation. you have to do Sn and then times r and then do rsn equation, and then minus both of them, then you can get the formula. Okay, that's the formula. And then for B, hence take the range of values of r. This is 1 mark, so you can just write the answer. It's -1 less than r less than 1. Okay, why is it that answer? Because because the bottom can't be 0, so the numbers must be in between this range. Okay, so that's all. You can go for next question.
Question number 9. Diagram 6 shows a part of an arrangement of several rectangles. The first rectangle has a length of 120 cm with a width of 189 cm. The length and the width of each subsequent rectangles is 3 over 4 of the previous measurement. Find the smallest value of n such that the area of the nth rectangle is less than 100 cm square. Okay, I'll be giving you guys 2 minutes to try out this question. Please do try out. Just don't please try. Just don't sit in the class and do nothing. Try it, please. It's okay if it's wrong. I just write the comments and thank you for responding from Charlene. Cactus pretty I'm sure many of you guys don't like progression, but there's no choice. You still have to somehow try to do in your exams. At least maybe like maybe you can score at least 4 marks if you know the basics. Okay, so don't give up yet. Okay, 9A. One, two, three, 4 marks. B. Find the sum of infinity. Sum of infinity formula recently only we did. I really hope you guys can recall or maybe try to refresh your mind. So Jimmy can explain this.
Okay, so for A, they're asking the smallest value of n, where area of n triangle is less than 100 cm. So basically, they're asking us to find n. So we can write, since they say less than, we can write Tn is less than 100. Okay. This is a geometric progression because the question say 3/4 of the previous measurement. That means you are multiplying 3/4 before each term. So it's geometric progression. So you'll use AR n to the n to power of n minus 1 less than 100. So we can find A, which is the area of the first rectangle, which is 120 times 189. And then we can find R by using term 2 divide term 1. And then you can substitute A and R into the formula. And then move around, and then you can insert log. And then when you are inserting log, check whether the log is negative or not. If the log is negative, then the symbol will change from less than to more than. Okay. And then use calculator, log 10 100 over 22680 over log 10 9 over 16. Then you'll get and then we get 9.427 and so on. Then you move the 1 to the other side, you'll get 9 is more than 10.427. So since it's more than, you have to so it's estimately 11. So it's n equals to 11. For B, they're asking sum to infinity. That's very easy. You just substitute the information you have into the formula and you'll get the answer 51840. So everyone understand? Can go next question.
If A is the first term and D is a common difference of an arithmetic progression, show that the sum of the first n terms of the progression is Sn equivalent to n over 2 bracket 2a plus bracket n minus 1 close bracket d close bracket. Given an arithmetic progression 5, 9, 13, 17, find the sum of the first n terms. So guys can try first. Okay, continue first. This is method 1, or you can also do method 2. Question B. Given an arithmetic progression 5, 9, 13, 17, find the sum of the first n terms. Okay, simple one, only 2 marks. Okay, but in order to do question B and C, you will need to know how to do A first. Okay, solve the equation 5 plus 9 plus 13 plus 17 plus something plus x is equivalent to 2277. So use the factorization method. Put two brackets equivalent to 0, make sure it's equivalent to 0 and make it into general form. Value of x into 122. And that's it. So revision room, do you have any explanation for this?
Okay, so for the A question, it's proving or deriving. So we have taught in the last class, so you sure should know. Since they say arithmetic progression and they want us to show the Sn formula, list out Sn in ascending order and Sn in descending order, and then you plus together both of the equation and then you solve and then you get the formula. So by this I think we have seen quite a lot of proving questions, so try to like remember it lah, so you can get like marks for it. Okay, then for B, okay, B is very easy. You can just use the formula, Sn formula, and get the answer. You can get the common difference by minusing term 2 and term 1. Okay, so for C, if a question says hence, then usually you have to use the answer from the previous question. Okay, so remember that if you guys use a different way or like different answer, then you won't get marks for the question even though your answer is correct. Okay, so for C, since we know the Sn is 2n square plus 3n and the total sum here is 2277, you can equate it. 2n square plus 3n equals 2277. Then we move the 2277 to the other side. Then this is a quadratic equation. You can factorize using a calculator, and then you'll get n equals to 33. The reason why we don't take the other n is because it's in negative form. Okay, so it will be ignored or rejected. So there's two ways of finding the value of x. We can either put t33, which is the last term, and x is also last term here. So T33 equals to 5 plus 32 times in bracket 4, you get 133. Or another way is you can use the SN formula and you can equate it with 2277 and you still get the same answer, 133. That's your answer. Understand, everyone? If everyone understand, then that's all for today.
Yeah. I really hope you guys learned something, and just don't try to give up progression. At least try to know the proving, so it can help you. Maybe at least 4 or 5 marks. So that's all. If you guys want the answer, I can send it through working. Alright? Okay, that's all for today. And today will be your last class with us as well. Alright? Thank you for joining for the past few weeks with us.
Thank you,
And good luck
everyone.
for your exams.
Yeah,
Bye-bye.
good luck too. Bye bye. Okay, thank you.